Hey folks, welcome to the very first episode of TECMK, and where we are going to deal with character animation. But before we jump into the acting and dialogue delivery and everything, there are three things which we need to understand. The bouncing ball, the walk cycle and the run cycle. These are the three exercises which will help us to understand the body mechanics, how the body works to different actions and so on. So once we are done with these three chapters, then we will be jumping into acting and eventually character animation. Create nerves primitive sphere. Go to material attribute, assign checker. This checker will allow you to see prominently as to what changes, and then change the scale up this shape to 6. Also create a cube at the base, hide the grid. This is the sphere or the ball, and this is the base on which the ball is going to bounce. Press insert and change the pivot point of the sphere just at the base. Check it out that whether things are fine or not. Keep the auto key on. So this is the place from where the ball will start bouncing. So let's key it. I presume that it will take 15 frames to touch the base for the first time. So 1 to 15, the ball is coming down. 15 to 25, the ball will go up. Anything takes more time to go up and less time to come down. So if I take 10 frames to go up, then it will take 7 or 8 frames to come down. It will come down here. So if the first time the ball is taking 10 frames to go up, the second time it cannot take 10 frames to go up, and at the same time it cannot go up to that extent what it happened earlier. Now it will take 7 frames to go up, and the up is also not that much up compared to the early one. Earlier it was here. Here we'll make it little bit less down. So it took 7 frames to go up. So it will definitely take less than 7 frames to come down. So let's take 4 frames to come down. And let's make another bounce. So 1, 2, 3 frames it is going up, and 2 frames it is coming down. So a ball is bouncing, that's it, nothing else more than this. Animation editors, graph editor. So since we have manipulated only one axis and we didn't touch the other one, so let's concentrate on this one. Now you see, this is the part from where the ball started bouncing. It came down, it went up, came down, went up, and this was happening. So definitely the place from where the ball was bouncing or it started bounce, the second time the ball cannot go to that level, because this happens due to mainly losing of the energy inside the ball. The third bounce, the ball will be going further down, and the last bounce can be further down. While we touched the base, we did it manually. So now we'll try to make all the same. This value is 6.206. We'll do one thing, copy the same value of this down thing and paste it in the others, so that the ball does not go inside the cube. The ground level is being maintained. Whenever an object starts coming down, unless and until it's a rock solid or it's a hard substance, if it's a bit of flubbery or little bit stretchy, the stretching of any object slowly starts to increase. So when the ball is coming down, I will also increase the stretch of the ball, and the stretch is the first. Stretch and squash is the first option of one of the animation principles. So what is the stretch? This is the stretch, right? So the value, as you can see, all the x, y and z are 6. That's equal 1 since it's a sphere. So while it is coming down and the stretching is increasing, I'll keep the value to 8. This much of stretch does not usually happen, but this is just for your convenience and for me to show you prominently that how things work out. The mass of the object is being retained at any given point of time. So if we are increasing the mass at any one of the axes, the other two axes has to be adjusted. If we are increasing the scale y by 8, then the scale x and scale z needs to come down. So right now it is 6, we'll make it to 4. Again, as I've told you, these extreme change does not usually happen, but this is being done just for representation purpose so that you can see it clearly. This is the perfect shape of the ball, and x, y, z, all the values are same. That is 6. As the ball is coming down, you can see that there is being change. the y-axis in which the ball is coming down is increasing, and to accommodate that increase, the x and z axis are decreasing. Again, when the ball is going up, the value is being getting to the normal 6. See here, this is 484. Here in 20, you can see 575. And in the topmost position of the ball in the second bounce, everything is 6. Well, again, when the ball is coming down, we will be increasing the value. But of course, this much of stretch will not be the same as what happened earlier. So earlier, if we have given the stretch to 8, now we'll give it to less than 8. It can be 7.9 also, but for your convenience, we'll make it to 7. Similarly, to accommodate that huge stretch, the x and z needed to be reduced considerably to 4. So since now in this time, the value did not stretch so much for y, so we don't have to take it down to 4. We can keep it to 5. As I've told you earlier, the mass of this thing or the ball is intact at any given point of time. So if we are increasing from somewhere, it needs to be decreased from somewhere else. Again, the ball goes up. As usual, you can see the values all are getting 6. And again, the ball comes down. So naturally, when the ball comes down, we have to again increase the stretch of the y. But of course, the stretch of the y earlier in the bounce was 7. So now the stretch of the ball will be less than 7. But of course, it's will be more than 6. So we'll make it to 6.5. Other was accommodated 5 and 5. So here in this time we'll make it to 5.5. And then the ball goes up again. Again the value comes to 6. And then the ball comes down again. We can change it here or we can just keep it intact. See, there can be a multiple of bounces after this also. And there happens it used to be. A ball cannot stop all of a sudden. But just for the purpose of our understanding, I'm not going into that details or adding more bounces and making things more complicated. I hope you understand. Ball is intact. As it comes down, stretches, again intact, stretches, again intact, stretches, again intact, and comes down. Okay. Earlier the ball was only bouncing, and now the ball is bouncing along with the stretch and squash. Now the ball comes down and it hits. So what happens after the sphere hits the ground? Does it immediately go up? No. For every action there's an equal and opposite reaction, as we already know. So once the ball hits the ground and the ball is stretched, the next immediate action will be squash. The ball is getting hit. It faces a resistance by this block, and in the same place it gets squashed. So what we'll do, we'll copy the same key of 15 and paste it to 16. We will squash the ball. The default shape of the ball is 6. So hence I will squash the ball to 4, or even I can squash it to 3. As told earlier, if the ball is reducing the size in one axis, then the other axis also needs to accommodate to make it fit. So what we will do, x and z will make it to 8. Of course, this much of stretch and squash might not happen, and usually does not happen, but as I've told you earlier, for the sake of our understanding, we will make to this much extent. So you see here, earlier when the stretch was there in the y-axis, the x and z reduced their own axis to accommodate the mass. And now, when the y-axis has been reduced considerably, then the x and z axis has to get increased again to maintain the mass. Similarly, once the ball hits for the second time, the amount of stretch and squash which happened earlier in the first bounce is not the same which will be happening here. I'll middle click my mouse and copy the same key here. So what is the squash amount which happened earlier? The scale value was 3. You can make it 6 and check the entire mass, the default mass. And now the scale value will make it not like a 3, but 4. And to accommodate this 4, we have to also, like it was 7, we'll make it, we cannot make it 6, we'll make it 4. So accommodate this 7, we'll make it 5.5. make it 5. 8, and to accommodate this we'll make it 7. So you see, since the sphere squashed in the y-axis, rather I should say reduced in the y-axis by 4, I have increased the value of x and z to 7 to accommodate the mass. Again it goes up, maintains the same value, and again it comes down. So guys, in 44 again the ball hits for the third time. So we'll copy the value and keep it here, and now let's see how much reduction can be done. Scale y was 4 in the second bounce, so it cannot be 4, it can be 5. And to accommodate this 5, what was done earlier? The value of 7 was there. So what we'll do is, we'll keep it 6.5. Again the ball goes up, and we are not doing it for the third time again. Now there is another important part, the third part, which we are going to introduce now is, any object comes and starts stretching, it gets obstructed on the ground, and only after obstruction it squashes. But what happens after that? After that, as we have told, for every action there's an equal and opposite reaction. The squash eventually gives way to stretch again. It means that the ball remains in the same position for one more frame, and it again stretches. Now how much will it stretch? Definitely it cannot stretch like this to the extent of 8, but it can stretch to the extent of 7, which is less than 8. And automatically, to accommodate this stretch, again the scale x and scale z needs to be reduced. How much was the reduction earlier? The reduction was to the extent of 4 for the first stretch. And now when it is taken for the second stretch, we'll make it to 5. The ball, it's retained its shape, slowly coming down, stretch is increasing. This is the maximum stretch at the contact point. And then it squashes, again it stretches, but the contact point remains the same, because if it does not remain the same, the ball cannot stretch again. And then it goes back again and retains its value. Again it comes back, stretches, squashes, and as usual, we'll keep one more frame over here and we'll stretch it a little bit more. But definitely the stretch which happened earlier to the extent of 7, I cannot take it in consideration. I have to make it less than 7. So it can be 6.5 or it can be 6 also. The other values, how much was the other value? 5 and 5 will make it, 6 will make it. Then it goes up again and again it comes down, squashes. Again it will stretch. That will be very negligible, of course. How much was the stretch? This was 5.5, 6.5, 5.5. It comes here. I'll do a very minimum stretch, maybe 6, and this I'll keep it to 5.8 just for the sake of keeping the value, little bit like this, and we'll visually just check out from this place. This is the third step of the bouncing ball. Yeah, the ball is bouncing, the ball is stretching and squashing, but still it looks far, far apart from the real life ball bouncing, and it does not give that feel. So what is that X factor that is missing? This is the X factor which I was talking of. Check out the translation Y. This is the translation Y. Now you see, these are the graphs which have been plotted. These are the 3 keys where they are being placed in the same position. So the shape is changing. Again going up, coming down, staying for 3 frames. Again going up, coming, staying for 3 frames, and so on. Did you look carefully at the nature of the line which is coming down? It is smoothly coming down and smoothly getting gelled with it. Again it is smoothly going out. So things are so smooth. We'll click on this one. Tangent which comes. So if I click on the tangent, so I can change it, and you can well see that if I change this handle, this part of the curve also gets affected. I don't want this. So what is the solution for this? Click on this one. Go to break tangent. Once you click on the break tangent, you see these two handles become independent of each other. And I do not want the smooth nature in which the ball was hitting the ground. The ball just directly comes and all of a sudden there's this sharp ending of the ball. This is what is being done by using the break tangent. Similarly, for this one also, I don't want the ball to get out very smoothly. I'll break the tangent, come over here and check out this thing. For all the points where the ball is hitting the ground and leaving the ground, hitting the ground and leaving the ground, I'll make every point of those as break tangent. So come here, already break tangent is done, adjust this graph. This is the nature of the graph. And what happens if we change this into break tangent? Let's make a play blast and see for ourselves. Now for the final checkup, we'll have a look at the graph editor more clearly. Translation X, nothing. Translation Y, yes, we have dealt with this curve for so long. Translation Z, we don't see anything. Rotation X, rotation Y, rotation Z. Scale X, yes, we do see something. Scale Y and scale Z. The first thing that we need to pay attention is scale Y. This is the scale Y, which we were manipulating all the time for the increase and decrease of height and all these things. So this is frame number 1 and the value of scale Y is 6. That is the default value of the sphere. And you can see that this value, like for example in 25 and then in 40, the values are 0. I mean 0 in the sense the values are 6. These are the points where the sphere or the bouncing ball has attained the maximum height. This is the height where the value is 0. Again, this is in 25, it's maintaining its round shape, perfect round shape. So it's 6. Again in 40, it's gone up, so it's perfectly in its original shape. But these are the places. This is the contact point, the first time when the ball was in contact with the ground. The value stretch, the stretch value was 8. And just check, if you would have made more up and down with this, it could have increased or decreased. So then it went down to squash. And then again, the stretch increased to 7. That's fine. Then it went up again and it attained the value. And again, when it went down, again there was stretch as usual. And again, the value is 7. Now, this is not acceptable. As we have told earlier, and as we know, that everything comes to a decrease. So if the scale value was 8 here, and the scale value is 7 here, then here it cannot be 7. Either we have to change the value of 17 or we have to change the value of 33. It's better that we take a call that we increase the scale value. So it comes down, then it comes down to this one. Okay, I'm fine with it. Again, if you can see that the stretch value of 33 is 6.5 and also the stretch value of 44 is 6.5. No, this is again not acceptable. Either we have to increase this value or we have to decrease this value so that everything comes up and down proportionately. If we draw a straight line from here and all these things joining together, then the graph can be slowly, it should be a downward graph. Whereas if you see this point, this one, the value was 3, the value was 4 and the value was 5. So if you see, these values are proportionately increasing or decreasing or whatever you might. But suppose if this value and this value would have been same, then I would have definitely asked you to change it. Or similarly, if this value and this would have been the same, then either we need to increase this value or we need to decrease this one. Let's go to scale X. As briefed earlier, these are the places where the sphere is at the maximum height and hence the value is being maintained to 6. Now here we can see that the value is 4. That is, scale X and scale Z, both of them had to be decreased due to the increase in the scale Y. Now we come here, again the scale need to be decreased. Well, I'm okay with it, 5. Again it went back, and again it was 5. No, this is not acceptable. Either we need to take it up or we need to take this down so that these points are on a slow decrease. We come here, and again you see these two values are the same. I understand that at this point of time the ball is reaching its maximum height, so the value has to be intact, that is 6, but it cannot be here. So let it come down. Just check the nature of the graph. Ups and downs, ups and downs. So wherever you see a constant factor, definitely you have to look into it and check what the nature of the graph is and accordingly adjust. Let's go to scale Z. This is the 0 point. These are the 0 points where the sphere is reaching its highest point. So fine. It is there. It was maintaining. It came down, and due to the increase in the value of scale Y, X and Z had to be decreased. And so we had decreased it to 4. Again, with the decrease in the value of scale Y, we had to increase the value of X and Z, and so it increased. Again, with the increase in the value of Y, these things, the scale X and Z decreased. It went to its normal shape 6, that's fine. But here, now you see, the value is 5 and this value is also 5. No, either we need to take it up or we need to take it down just to maintain the same angle which was followed for scale X. Again, what you can see, these two values cannot be the same. Guys, I think you're getting my point. Now again, if this value comes down to here, I need to take it up. And then again, it needs to go down. Check the nature of the graph. Please look into it attentively. Look into those 3 graphs together, and I hope you'll be able to figure out what is the similarity and how you should adjust the graph. Let's make a play blast of the bouncing ball again. And now let's compare these two bouncing balls. If you look carefully, you will see that version 6 has that little X factor which is being added and which it has attained after we had manipulated the graphs in a logical way. So please have a look of your exercise and try to follow exactly what I have said. So guys, this was pretty much of the bouncing ball, and let me know if you have any questions, any clarifications pertaining to this chapter, and I'll be happy to answer it. Once you are done with it, we'll go to the walk cycle.